Memory management. It is managing the memory in our application. Whatever memory we create for our objects or for our variables, those must be cleared if those are not used. Once the work is done with the objects or variables, we need to clear them from the memory. We have a concept called ARC, automatic reference counting, which does all the work. Previously, before iOS 5, there was manual memory management. As a developer, you were the responsibility to allocate the memory as well as release the memory, cleaning the memory. But from iOS 5 onwards, we have a concept called ARC, automatic reference counting, okay, which works in compile time. Which works in compile time means basically once you run the application, there are two phases. One is compile time phasing, another one is runtime. Compile time is one thing, runtime is one thing. In compile time, the memory will be allocated and the linking of the libraries will be happened. Everything will be happening in the runtime, basically checking the code is properly written or following the proper syntax or not. If the syntax is not properly followed, it gives you the error warning or error in compile time itself. Runtime errors are different. Compile time errors are different. Compile time is basically first phase of the application running, where everything will be checked. The syntax are followed properly or not. The linking of the libraries, allocating the memory, those things will be done in the compile time. The ARC works at compile time, automatic reference counting, okay, which was introduced from iOS 5 onwards. Basically, what happens is when the memory is allocated for every object, there is something called reference counting. Reference counting is number of owners which are holding that object. Number of owners which are holding that objects. If the reference count is 0, means nobody is using that object, we need to release that memory. We need to clean that memory. ARC internally uses reference counting. Reference counting is the mechanism that is used to keep the memory or clean the memory. If the reference count is 0, that is cleaned. If the reference count is not 0, that is still persisting in the memory. What ARC does, ARC in regular time intervals, ARC keeps checking the reference count of the object. If there are 10 objects, the ARC system, what it does at every certain time intervals, ARC keep checking object, what is our reference count, what is our reference count, what is our reference count. If the reference count of that object is 0, immediately that the object will be released from the memory so that the memory will be freed up. Okay, the theory also same thing. This is almost to 90% of the theory only, but you need to definitely, there is a definite interview question on this. Swift uses a system of memory management called automatic reference counting, which is called ARC. ARC keeps tracks of how many references are there to an object in your code. ARC checks how many number of owners are holding that object at particular time interval, at particular time, at point of time. When you create a new reference to something, the reference count of the object increases. When there are, by default, every object contains only one owner. We have seen the relationship between son, dad, and car relation, right? If son wants to have the same car, either he can share the reference. When he simply uses the same car, the reference count of that object is 2. There are 2 owners. Bank account, we can say like we have 2 people can have the same bank account, right? Is that kind of thing? Okay. Memory management functions and it uses or handling Swift language through automatic reference counting. ARC is used to initialize and deinitialize the system resource by releasing the memory used by class and same thing. Basically, initializing means creating, deinitializing means releasing. We have seen deinit method, right? I'll also show you again. ARC keeps track of information about the relationship between our code instances to manage the memory resources efficiently. Basically, it keeps checking the number of owners of the object. ARC allocates a chunk of memory to store information each and every time when new class instance is created. The first object, first reference count, basically how to create the object by using init, right? When you create any object, what happens is one object will be created. The object reference count is 1. By default, it is 1 once you create it. When you call dinit, when the dinit will be called, dinit is called automatically by the runtime system, right? When that is called, when there are no owners, when there are no owners, then the dinit will be called. Information about the instance type and its values are stored in memory. When the class instances is no longer needed, when the class instance is no longer needed, it is automatically frees the memory space by dinit for further class instance storage and retrieval. If any particular object is not holding by any reference, then that is released by calling the dinit method. ARC keeps track of currently referencing class instance properties, constants, variables, so that the dinit is applied only to the unused instances. Okay, leave that. ARC maintains a strong reference to those class instance properties. A strong reference, I'll tell you what is strong and what is weak. Let's say what we do generally, assume that there is a class called aeroplane. I am creating an object, an aeroplane. I create an object. What happens? This is the object, and that we are assigning to the particular variable. Here is the owner. An aeroplane is holding the aeroplane object. He is still holding, so the reference count is 1. Whenever we call init method, one object will be created. The object reference count is 1. I used the object and I want to release the object. If I do not use the object for longer time, what happens is ARC comes into the picture and releases the object. ARC releases the aeroplane object if it is no longer needed, if it is not used further. Okay, ARC automatically releases the memory. Previously, what we used to do is when there was no ARC, as a developer, we need to write some extra code to release the memory. An aeroplane dot release. There was a method called release, but release method is not available right now. Even reference count property was there. Now, no reference count property also not there. Init assigns the reference count with 1. Dinit decreases the reference count by 1. That's it. Dinit actually what actually dinit does? Dinit releases the memory. Simply, not even decreases. Dinit releases the memory. ARC releases the object memory once the reference count becomes 0. What ARC does? ARC always checks for the reference counts of the object. Whoever reference count is 0, the object will be released. Only very simple concept. ARC keeps checking the reference count of the object. How many number of owners are holding the particular object? If the number of owners means reference count is 0, means nobody using it, so it releases. All variables declared in a class are by default strong reference. I'll tell you what is strong reference, what is weak reference. There is something called weak also. Strong, weak, and unmode. I'll tell you all these things. Those are very, very important. Here, the memory management, the entire work is done by the ARC. But still, there are some chances where ARC also fails to release the memory. There are certain cases where ARC fails to release the memory. That case we need to handle. When that case occurs, I'll tell you that in practically. Case to handle by the developer. ARC sometimes fails to release the memory. What is that case? This is the case. Assume that there is a person object, there is pen object. There are two classes. One is person class, another one is pen class. I am using pen object in person class. I have a variable which is pen in person class. Similarly, I have a person object, person variable in pen class. Basically, there are two classes, class A and class B. Class B variable is used in class A and class A variable is used in class B. Both are using interchangeably. But when ARC tries to release the memory, what happens when ARC tries to release the person? Person contains different set of variables A, B, C, D, addition, subtraction, sum, and also it has pen. ARC tries to release the go here and tries to release the pen. In pen also we have a person. Person object again comes here. In person we have pen. It comes here to release the pen. To release the pen, it has some property, it has some variable that is person. Again comes here. When this becomes cycle. Here, ARC trying to release the memory, but it is unable to release the memory because both are used each other. Both variables are used by each other. This is the case we need to handle. In such cases, what we need to do is we need to use the weak. What is strong? By default, whatever you create, by default, whatever variables we have declared in a class, everything is strong only. Okay. What is return cycle? 100% question again. Return cycle occurs in languages where the memory management is based on reference counting, where two objects are pointing to each other strongly. ARC can't find a way ARC can't find a way to release them. In such cases, memory leaks happens. Memory leaking means ARC is failing to release the memory. The memory is still occupied on the RAM, but it is not used but unable to release the memory. Memory leak means leaking the memory. Leaking the memory is unable to release the memory. Okay, some example I will show you here. Return cycle occurrence also I will show you. Vehicle, yeah, again we have the same kind of example here. Vehicle, car. Value type means when you use structures, this is what happens. We already see when you use structure, what happens? Separate object will be created, but reference count is not applicable for the value types. Only it is applicable for the class types. Class means reference types. What happened here? Dad car, one car is created. Here it is the initializer. What happens? This car contains the reference count is 1 because we are calling the initializer, so it is 1. Son came and asked, son, I want a car. When he is assigning, Sundar, there is no week. When he is assigning same car, son, my dear son, you also use the same car. Then what happens? This car contains 2 owners. Here it is the 1. Here it is the 1. Then the reference count of that object is 2. Even though the son is not using the car, still dad is using in some cases. If son is not using, still the memory will be holding. Still the memory is available because even though son is not using, if son is not using means the reference count is becoming 1, -1. There is 2. When son is not using, one is gone. When one is gone, still the reference count of that object is 1. Dad is still using that car. Then the reference count becomes 1. Then if dad is also wants to release the memory, wants to not to use the car, then the reference count of that object becomes 0. Then the memory will be released. I'll tell you what is weak here. Yeah, this is the code snippet where dad car, when dad car is there, car is created here. This is initializer, right? When you create object, one object will be created, car object is created. The reference count 1 is assigned to that, and the owner is the dad. And dad is using this car. Car is he driving the car, blowing the horn, stopping it, and he want to release it. He want to releasing it in the sense you don't want to use that. His work is done with that object. Then we can put, if you want to see it real time, I'll tell you that, like we need to put nil. If you put nil means this owner is not is This dad is not owner of anything. This dad is not owner of anything. Then I'm putting just nil. Nil means his ownership is closed. Then what happens? Car is there, but the reference count becomes 0. This means nobody is holding this. When nobody is holding, what happens? ARC comes into the picture and clears this memory. ARC comes into the picture and clears this car from the memory. This is the actual life cycle of the object. In ARC, in interviews, what they ask is, what is ARC? ARC is automatic reference counting, which is used to manage the memory automatically in Swift or iOS. What is the mechanism that is used by the ARC? ARC uses the automatic reference counting. Reference counting or retain counting also we can say. Retaining is retaining the object. Retain count or reference count, both are same. ARC uses the reference count mechanism to keep the object in the memory or release the memory. Okay. Is ARC compile time mechanism or runtime mechanism? ARC is compile time mechanism only. ARC is compile time mechanism only. Actually, most of the time we do not use nil here. Automatically, what happens when you compile the application, when you hit the command B for compiling actually. Command plus B is the shortcut. Command plus R for the running. When you hit command B, what happens is ARC checks, okay, here I need to create an object and assign the reference count. Here I need to release the memory. Releasing means internally, automatically ARC keeps something here. Something similar. This thing will be put by the ARC if the object is not used. Generally, most of the time we do not write this. ARC itself at the compile time it inserts this statement. Okay, dad car is used and he no longer wants dad car. He no longer wants car. So what happens automatically? ARC keeps this line of code in compile time. Okay, what is strong and weak references and unwound references? That is also important. Yeah, strong and weak. What happens is, let's say here we're having dad car is created. Reference count is 1 because there is only one owner. He is using the car and some other day son came and son, dad, I also want car. The car can be given in 2 different ways: complete ownership or partial ownership. When you use partial ownership, what happens is when dad does not want any car or son does not want, either son or dad can be collapse this object, collapse this car. Means here reference count is 1 only. The reference count will not be increased in case of partial sharing. Partial ownership. Dad said, my dear son, use the same car. He said, use the same car, but he's not giving complete ownership here. When he is weak, he's not giving complete ownership. Actually, here he's simply taking the car, but he's not the owner. Here, son is not the owner. Only dad is the owner. When dad wants to release the memory, he can release it. I'll show you this with practical example. Only thing you need to remember is when you do not put weak here, what happens is the reference count increases. The reference count increases because there are 2 owners. When you use weak here, the reference count will not be increased. That is the only difference between strong and weak. When you assign any object strongly means without this weak, what happens? The reference count increases. The reference count of that object is increasing. Here, this is only to basically in real time we assign the same object multiple times so that the reference count becomes 4, 5, 6 also. For your understanding, I'm just taking 1 and 2 only. In case of if you use weak, the reference count will not be increased, but object will be shared. Object will be shared. In practical, I'll show you. Here, dad is using, son is using, dad is using, dad is using. Dad at the end, dad does not want to the car, so he put nil. When he puts nil, even son cannot use the car. Even son cannot use the why? The reference count was 1. It became 0 when dad does not want the car. In case of strong, yeah, we have strong. By default, everything is strong. You don't need to mention any keyword here. For weak, you need to mention. For strong, you don't need to mention. Same thing, same concept here. Dad car. Car is there. Dad purchased a car. The reference count of that object is 1. Here, dad is the owner. After a few days, son asked, son, dad, I want a car. What he did, take this car, but you also get the ownership. You also can do anything. Then what happens in case of strong, the reference count become 2. Dad uses the car and dad does not want the car. He can collapse. Dad does not want the car. He can simply say, I don't want. But if he says, I don't want, what happens? The owner is gone. Dad owner is gone. The reference count become 1. It was 2. Now only one owner is there. Even if he does not want, then he can release some car equal to nil. You can put, then it becomes 0 and the memory will be released. That is, those are the different interview questions which are asked. What is ARC? Does ARC run in compile time or runtime? What actually mechanism used in the ARC? That is reference counting. What is strong? What is weak? What is unwound? Unwound we haven't seen. I'll also tell you that. And what is reference counting? So return cycle. Return cycle is when there are two classes which are using each other strongly, then the ARC system fails to release the memory. Then that is called return cycle. I also show you what is the example you can tell to the interviewer. This is how you need to explain what is return cycle, why it occurs. So I'll also show you in practical now. Take the project. I'm again taking command line tool on memory management. Let me create a class called, let me create a class here itself. Class person. Class car. Person is having a property called name. Where he is having a car, but car is car. Okay. Anyways, car. Here are an optional property. Here, car let model. Car model. It is a string. Then let one of this car is a person. Option. By default, there is no owner. Anyways. Come on. Yeah. There are two classes. One is a person class, another one is car class. Person has two properties. The property is the name of the person and car which he owns. And he may or may not be having car. So it is this optional. And car is a class. Car contains model. That is the name of the model. And owner is some person who is owning this object. By default, there is no owner here. Anyways, let me create person. A person. So a person equal to person. I'm creating object, so the reference point becomes 1. Okay. Let me also put D in this layer. D init. Sorry. D init. Person is no more. Let me functions work. I am working. Okay, let me. Yeah, person is the thing here. Person is created. The reference can become one. A person dot name. I am putting. Even we can have our own initializers. Ready. A person dot. He wants a car. Let me create a car as well. Let a car equal to car object. A car dot owner. Owner equal to a person. Or else I can put a car dot equal to a car. It is asking for a car. I am creating car object given here, and car can have few properties. Let me write few functions. Move is a function. Is moving. Car is moving. Okay, even you can remove this for now. Now let me remove this as well. Car has only one property, that is the name of the car or model of the car, and car is moved. Car can be moved. A person dot car dot move. Car is moving. The person object created. So what happened? The reference count of this person object, a person becomes one. Person is created. The owner of this person is a person. The reference count is one owner. I am using this when setting some properties, and even car object is created. Car also contains one property. Reference count is one. This is also object, right? When init is called initializer. When init is called, when reference count becomes one. Okay, and I am assigning that car. I am assigning that car to some person. Now what? And I want to. I just want to collapse equal to nil. Let me put this as a. This is an optional to show you. Okay, person object is created. Person name we are setting. We have created a car and assigning that car to the person. Person now has name and car. Person is moving the car. Person is moving the car, and the person he want to collapse everything. He want to collapse everything. Okay, we are not assigning let constant. Make it where. Okay, I just want to show you the deinit method. Let's run it. This is actually called optional chaining. Can you guys hear me?
Hello.
Hello, sir. We can't hear your voice if you are speaking.
Sir, unmute yourself.
Yeah, sorry. Yeah, here there is a person. There are two classes. One is person class, another one is car class. I created two objects here. For the person, I am setting person, your name is so and so, person, your car is so and so. When you create two objects here by using initializer, the reference count of that object became one. Now, person, the like this person object, whichever is created, is hold by the a person, the car is held by a car. There is only one owner for the person, there is only one owner for the car. Now the reference count is 1 and 1 for person and car. I am setting the name of the person. I am assigning the car. Person, your car is, you purchased this car. I am assigning this car. Then the car reference count become 2 because here is the one owner, car is the another owner. And car, I am using the person is using the car. Person dot car dot move, and person wants to collapse everything. Okay, when he collapses everything, see what happens. Person is no more. Person is no more. Okay, and what we can do is, yeah, person we are collapsing, we are breaking the ownership of the person and person object. A person is the owner and his ownership to the person. It became what happens when you set this, the person who reference point was 1, it became -1 now, so it becomes 0. When it is 0, the object is released. Once the object is released, this method will be called. Deinit is the method which gets called when releasing the memory. Init is the initializer, deinit is the deinitializer, right? Any doubts here? There are two classes. Repeating, there are two classes: person class and car class. Person class and car class. Here, person contains two properties: name and car. Name and car. Car is one class. Car contains only property, that is model. Which model of the car, and it has two functions. One is move, another one is deinit. Another one is deinit. Here, I'll also show you one thing. A person dot car. He does not want to use the car. He does not want to use the car. When he does not want to use the car, what happens also see. Let me directly put this a car here. Repeating, person object is created. For person, we are setting person, your name is so and so. If you want to even to make it clear, let me make it. Person, your car is this car. Directly creating the car and assigning it. Now, person contains reference count is 1 and car reference count is 1. Wherever you call initializer, the reference count created, right? The object is created, and for that particular object, we are setting the reference count. We are not setting, automatically the reference count becomes 1. Is a car. Now, person does not want to use the car. What he can do, he can collapse it. How he breaks the ownership? This is how, when you put nil, you can break the ownership on it. Here, car is created, car we are assigning person, your car is so and so. Car, he is using the car, moving, person dot car. What happened? Car is no more. What happened when you put nil here? There is only one owner to the car, that became 0 here. That became -1. Once it becomes -1, what happens? The ARC comes into the picture and clears the memory. It is cleared. When you put for person also, when you put nil, person also cleared because person ownership was 1. Person reference count is 1. It will become 0. If you put something like this, let a car, R, and when you assign this, see what happens. Instead of using this, I am using car. So I created a car here and I am assigning that car. Here, if you see here, the previous code, Car is cleared as well as person is cleared. Now see what happens. Car is created, person is created. Now this is one. I am assigning car here, car is assigned, and car is, I'm moving the car is moved and clearing it. Even if you put car equal to nil, this method is not called D, it is not called. Why? Because there are two owners. So A car is one owner, car is another owner. We are assigning here, right? When you are assigning, means ownership is sharing. Here ownership is shared. Even though you